Across Europe's fields, satellite eyes track change with daily precision. They also reveal floods when rivers surge beyond their banks. From crops and coasts to cities and forests, Earth observation powers emergency response, agriculture, climate monitoring, and urban planning, with Copernicus data increasingly embedded in processing chains. Today, that Copernicus trove tops 47 petabytes and keeps growing. In DeFab, we aim to create Europe's AI factory for Copernicus data at scale. Our consortium spans industry, research, and European HPC. DeFab's goal is to provide unified access to distributed data sources, run workflows where the data leaves, minimizing movement, and accelerate timely Earth observation analysis through AI-driven metadata extraction that makes content instantly findable. Our current system involves various key components. G-Core collects Copernicus imagery and extracts AI-driven features. Those outputs flow through Rushio's REST API to the unified catalog for persistent queryable registration. ForthSnot orchestrates these workflows end-to-end, and ultimately, users can query the unified catalog to fetch all those data. Together, these components reveal the full architecture, retrieval, extraction, cataloging, and orchestration, operating cohesively in DeFab's second increment. Our workflows are orchestrated end-to-end. From a friendly interface, an administrator submits a parameterized job to Argo, selecting tile IDs and other required options. The platform then uses packaged containers, validates inputs, deploying seamlessly to cloud or HPC backends. After submission, the workflow unfolds as an automated tree, fetching assets and metadata, orchestrating processing steps, running the selected flood or crop model, calculating derivative indicators, and finally submitting metadata back to Rushio for catalog discovery. Our two pilot models, field parcel delineation and water extent mapping, run as Argo steps on Kubernetes, processing satellite scenes, classifying areas, and automatically generating metadata and quality flags that feeds the catalog to speed search and reuse, keeping results machine-readable and traceable across iterations. Following review, we also retargeted from neuromorphic chips to GPUs. Neuromorphic ecosystems remain limited, whereas GPUs excel at dense deep learning. We apply an evaluation methodology balancing power efficiency, time to results, and data movement costs to inform deployment choices. DeFab offers through Rushio a single unified metadata catalog that harmonizes multi-sourced and AI-derived metadata and exposes interfaces so users and services can retrieve consolidated and stack-compliant information across sites efficiently and securely. Rushio exposes a rich set of open API documented endpoints that handle the metadata management, such as metadata insertion or update. For convenience, Rushio also ships a Python client with CLI commands that offer convenient methods, letting teams upsert or query catalog entries straight from the terminal. Finally, we test impact where it matters. Inside user pipelines, RSS Hydro and Hydrosat consume DeFab outputs through Rushio, add G-Core feature layers to their models, and assess improvements in flood and crop modeling. This downstream validation confirms the architecture. Unified catalog plus AI-derived metadata translate into measurable gains in performance and effort. In the next increment, the platform scales and specializes. Skim goes live on Melixina, serving a hierarchical stack catalog of AI outputs aligned with Rushio. Daci delivers production Copernicus ingest and a hot cache, publishing assets to Melixina S3 and funneling metadata into Rushio. G-Core hardens and runs workflows across cloud and HPC, and Rushio completes the unified stack catalog and exposes search APIs to pilots. Lastly, Forth federates multi-site, data-aware execution near data, and pilots validate further smart agri and water pipelines end-to-end. All these next increment pieces converge into a data architecture that unifies metadata, runs workflows near data, and delivers Copernicus insights to users at scale. DeFab closes this chapter with strong community ties. We discussed catalog evolution with the Ruscio community in San Diego, presented progress at the High Performance, Edge and Cloud Computing Conference in Barcelona, joined Synergy 2025 in Luxembourg to advance AI and HPC collaboration, and ran a technical workshop at G-Course headquarters to align engineering before deployment at scale. These engagements turn feedback into features and pilots into practice. With partners aligned, users engaged, and standards embraced, we move forward, confident, collaborative, and focused on impact.